Right. So apparently I'm supposed to keep this close to my mouth so the people on the stream hears me. But I'm from Elastisys. I work as an account manager. I take care of our customers and make sure that they're happy. We work in cloud native, mostly with Kubernetes, making sure that companies that want to utilize Kubernetes in a safe, secure, and good way has possibilities to do so while we manage their Kubernetes clusters. So as any massive company, we're 50 people, you know? You have to start in a basement somewhere or a garage. Our first address was registered on one of the co-founders of the company's garage. So you know where's soon the next Microsoft. Exactly. Tonight is not at all about me. I'm not a technical person at all, but we do have a lot of PhDs on our company. Like a fifth of the company's employees has a PhD, I think. And one of them is presenting tonight, Mohammad. So I will leave it to him, and it's because of him you're here, I'm guessing. And he's going to talk about this. So have a good night, and talk to you later.
Hey. Thank you, everyone, and hello, welcome, and hello, YouTube. So today's talk is about cloud-native technologies that you cannot ignore so that we can somehow revolutionize our software development processes. But a bit of information about me. I'm Mohammad Reza Saleh Sedghpour. Just call me Mohammad. It's easier for everyone. I'm a team lead and senior cloud-native engineer at Elastisys. I'm also a CNCF ambassador, so I'm trying to promote CNCF projects that we have, and also I'm really interested in contributing to open source in my whole life. So for the past year or more, I was part of the Kubernetes release team from version 28 since to the current version that we just started this week. To be more precise, yesterday. So, and also, I'm a cloud practitioner, also researcher. I do research. My whole PhD was about cloud native technologies. And let's connect on LinkedIn. Scan this code. And yeah, that was it. So let's move on to cloud native. Before we start and jump into the topic, let's see what is the official definition of cloud native. I want to just read it loud. Cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. This is the definition from the cloud CNCF Foundation. And also, you can scan this QR code to see this page. With this in mind, here is the list of cloud-native technologies that you cannot ignore. Easy, right? So I guess we can stop here. But just kidding, joke apart, we want to break this down. So one question for you. Are you using cloud-native technologies today? Right. Great. And to what extent are you working with that? Are you having it in production? Great. Nice. Okay. So let's talk about cloud-native technologies, but let's travel back in time where we didn't have any cloud-native. Let's use this time machine, travel back to 2010, something like that. We had cloud in those days, but we didn't have cloud native. So let's start a startup. Let's build a simple e-commerce called Kepnekase, if I pronounce it correctly. But what do we need for that? We need the so the easiest way to build such application is to have, for instance, some VMs for some databases that we are familiar with, and some web servers that the application is running on top of that, and also a load balancer for multiple virtual machines of application. And it should work fine, I guess. And but as our business grows, the traffic is also growing. We are having more income. It's really great. Everything is happy, but and we also our engineering team is basically a development team of front-end engineers and back-end engineers. That was it. I worked in that industry for some years, and it was like that. But at some point, we reached to a level that we couldn't really handle all of those servers, all of those machines. So we started to have and hire a new team. Let's call them sysadmins or DevOps team. And we had them. Their responsibility was to maintain the servers, keep everything up and running, the application, also streamline the process of deploying application to that server. Work-life balance in the DevOps team in those days. So the business gets to a growth phase, and the application just grows like crazy. The size is like growing. We have so many features. We also the DevOps team needs to have multiple tool set to keep this environment up and running. So in the management team, we have this idea of having this problem with the engineers that they cannot really work well because the application just grows. And we wanted to break the team in multiple teams, multiple smaller teams, and so that they could develop feature easier, faster. And so we decided to break the development team. Also, we hear that maybe we could also break the application itself to a smaller part and connect them together. Like this, for instance, this is my initial idea of a simple e-commerce application. Now we are just reaching to 2013 or 2014. We hear that there is a new concept of containers. Containers was not a new concept at that point. We had this concept, I think, from 80s, before I was born. So during those days, it's basically just a network namespace that we could do in Unix systems. So we could use that, but in early days of these containers, and actually, just to remind myself, yeah, okay. So to be able to manage such, for instance, create a new network namespace and then put the application there and then create some network adapters and then connect them to the host level network, we needed to have something to automate this process. We cannot do it manually every time. So we had runtime engines, container runtime engines, that they are responsible for such thing. In early days, we had Docker, but it's not supported anymore these days. Not supported, but it's not really common to use that. But the famous one is that I really like is containerd. So I could also use my cheat sheet. So it's a CNCF graduated runtime project that supports, for instance, image pool from some registries, and also you could run the container and then create the network and also add the new network interfaces if you need to that namespace. So it's pretty famous. Also, it's really stable these days. It's super lightweight, and so it doesn't need any extra maintenance, I would say. It works as a daemon set on the nodes. So the stack of our application looks like this. These are all containers. So, but we want to manage them. We want to orchestrate them as we need. We want to scale them based on our traffic, for instance. So my favorite project, Kubernetes. So it's super famous. Do you have any experience with Kubernetes? Nice. Everyone is familiar with that. So I guess we could say a lot of features about Kubernetes, and it's just growing super fast these days. 3 releases per year. It's a lot, and it's has a lot of features: automated rollouts, rollbacks, service discovery, load balancing, storage orchestration, self-healing, and a lot of other stuffs. So our stack now looks like this. We have a bunch of containers. We have put them on top of some virtual machines, but they are not connected. They cannot talk to each other. We have to somehow wire them and cable them so that they could connect to each other. For that, we need a glue, a network glue. I personally like Calico. It's easy. It's old enough. It's super mature. And it supports network policies for instance, security purposes, if you want. And also, you can have general access controls. It can be executed at a scale. And also, you can have multiple data planes, such as Linux IP tables or eBPF or any other things based on your needs. So just check this project out if you're not familiar with that. But it's quiet. And also one other feature is that you can connect Kubernetes workload with non-Kubernetes workload. That is one of these features that I really like about this project. So now the stack looks like this. Everything is connected. All the containers can talk together. And everything seems to be happy. But what if an incident happens? How we are going to troubleshoot that? We are somehow blind in such environment. Consider that we have, maybe our business needs to have thousands of services. In such case, we cannot really troubleshoot easy. And one other thing that was I should talk about before going to the next part is that we want to put all of those container images somewhere. We want to store them, but we don't want to pay for that. For instance, for commercial services that there is in the market. So we could use, there's a project called Harbor that you can store the images of your applications there, and it supports, for instance, it has security and vulnerability analysis. Also, we can also sign and also validate our containers, our images, and also it has an API and also a web UI that can be integrated to identity providers that we have. So let's move on to the observability part that I was talking about, that we are blind somehow in such environment. So one of the projects that I really like to play with almost every day is Prometheus. We can monitor, and also we can monitor the whole stack, all the metrics such as CPU usage, memory usage, and all of those things. And also set some alerting rules based on that. If something happens, we could detect that it's not working properly. And also we could have powerful queries with PromQL or query language. And also we could store dimensional data. and also we could integrate it with many libraries and many other tools that we are using. So the community is working really great with this project. But Prometheus itself is not scalable. We want to make our data, our monitoring scalable, and also we want to have it for longer period of time. So the next project is Thanos. Thanos can combine the metrics from different Prometheus servers that we have into one place, and also if we have a big query, if we have a huge query, it can also downsample and also compaction that query so that it's faster and also executable in general. And also because it can be integrated with third-party storage providers, it could also to some extent support unlimited retentions. So now we have our metric collected, but these metrics are a bit hard to understand, so we have to visualize them in some dashboards. So Grafana is the next tool that I really like personally. We can mix multiple sources to have a meaningful dashboards, and also we could have live dashboards, dynamic dashboards, and also it also has a rich plugin ecosystem, so you could connect with to even databases or even local files. You can present local files there, and it's a really cool project. So that's about it. We have all the metrics, but metrics are not telling the whole story always. So we want to take a look at the logs. The other project that I really like is FluentD. FluentD is responsible for collecting logs at container and OS level. So you could capture all the logs and unify them in a JSON format, and maybe you can store them, send it to be stored somewhere else. Also, it's reliable, also high performance. But again, we didn't store the logs yet. We want to have a place to store that. So we want to have a central solution for that, and that solution is OpenSearch. So we send the data to OpenSearch, and it's being stored there. But also it supports for advanced vector and hybrid search. We can use SQL or pipe processing language to query data and also create some dashboards. Also, it's super fast and scalable in all the terms. I've seen that people in some industries, they are using OpenSearch as a search engine, actually. So it's quite fast. And also, it supports the cross-cluster replication. And also, one other cool feature is that if you want to detect anything about your workload, you can integrate some machine learning models into it, if you're interested. But I've never tried that. So now the stack looks like this. We have everything up and running, and we have a full eye all over the stack. But the other issue is that we want to secure cloud-native environments. How we can do that? The very first project is Open Policy Agents. So maybe I could also take a look at here. So we want to enforce some policies regarding controlling the resources and check if the cluster complies with the policies that we have defined in the very first place. These policies can be enforced to namespace level. For instance, these policies could be restricting pulling images from trusted registries, for instance, like the Harbor that we have used. So this project is super cool in that regard. And the other one is that we want to be able to make our users, our developers, or our administrators log into our system and use our clusters. And Dex is the other project that helps us with that. We can use, for instance, the existing identity provider that we are using in our company, for instance, with LDAP or SAML or OAuth. And also, we can provide the single sign-on by them and connect them, integrate that to our cluster. So this is a really reliable project that we can use. And so just creating a new user is basically just adding that user into our identity provider. So the other one is that it's Falco, and Falco is it allows us to detect threats in real time, and we could define some policies for that. For instance, we want to make sure that no one is going to, for instance, do an SSH to our containers. Falco does that. For instance, it looks for we can also detect some unwanted behavior by doing some sort of system calls. So because everything we do, there is some system calls happening underneath. So it detects those things, and if it's unwanted, it can detect it. And also, it's customizable, and it's really stable as well. And the other thing is that normally we want to have our nodes, our VMs, to be upgraded with the latest security patches from that OS that we are using. So doing it manually, it could be really tricky. We want to make it automated. QRD or Kubernetes reboot daemon is the tool for us. So it basically watches the presence of the reboot sentinel file and make sure that only one node updates at a time. So we don't want to disrupt the whole operation. Also, we could defer the reboots if there is an alert from Prometheus. So in general, it makes sure that we have graceful node reboots. So we don't schedule any workload on that node, and we just remove all the nodes from there and do the upgrade and then reboot that. So QD does that for us. And the other one is 3V. Also, 3V is a security scanner that targets container images, file system, Git repositories. It can detect, it can target so many things, and also it can scan for known vulnerabilities that we have. And it just basically shows us that, for instance, this container image needs to be, for instance, upgraded or something like that. So basically, it just helps us to detect those misconfigurations in our stack. So that's for it. And the other thing that we want to have is that we want to secure the pod-to-pod communication with some certificates. And normally, those certificates, we don't want to pay a lot for the certificates, so we could use the free certificates. But those are not lasting for a long time, maybe 3 months. So we want to renew them every 3 months, and it should be super easy for us. Cert Manager is responsible for that part, to create those certificates. Also, we can use them in our cluster. So now we have also secured the cluster. So everything is running, everything is observable, and everything is secure. The next step is that what happens, what we are going to do if something happens in our cluster. So how we are going to roll back and how we are going to survive the disasters. So then the basic answer is to have some sort of backups. So we want to have reliable backup and restore. So it can Valero can back up Kubernetes resources and volumes, and we can also schedule those backups in, for instance, every week. Also, we can define some pre or post backup custom operations. For instance, we could send a notification that the backup is done, for instance, or failed if something is not working well. So now we also have the backup. The cluster works perfectly fine. It seems so. But it was 16 different tools. For a DevOps team, it could be super harsh. Are you using any of these tools? All of them? All. How is your experience? How is your experience with the tools, with maintaining them? Yeah. Yeah, but exactly, and that could be sometimes really horrible. Even the maintenance, and even the upgrades sometimes fails. But actually, the good news is that Elastisys is here to help. We have open sourced our compliant Kubernetes. We have pre-configured all of these tools with other extra tools that you can see there. Also, you can scan it here and see all of these projects. It's pre-configured. It complies with the regulations that we have, and it works super well in that regards. And if you need any help, of course, Elastisys is there. So I guess I finished a bit early. Yes. Yeah. So, any questions? Yes.
Yeah, I didn't quite understand. I didn't quite understand lots of these things. Like for the example, that network connection layer, whatever that was called.
Yeah, Calico.
Like usually when I have like a few Docker containers, I just use the host adder, like the virtual, like the IP addresses between them. So what does this exactly do, that network layer?
This one. Yeah. So let's say that you have 3 virtual machines, or that are not on the same physical machine. So, and you have one container running on top of each of these machines. You want to be able to connect these things together. When they are in different physical machines, you cannot connect them, right? So these network, these CNIs, or I forgot what was it stands for? Yes, I forgot that. So we can connect them using them, and also, for instance, you can have a router to see what is the IP address of that container, for instance, in machine B. So you want to you have a router there, and those these CNIs are helping us with those things.
All right, so it talks to the router.
It provides the router in itself. For instance, it might use, for instance, BERT, or you could use IP in IP, and yeah, that's pretty much it. And also, if you want, for instance, for instance, 2 containers want to talk to be able to talk to each other, and no other containers, then CNIs it can also help us with the network policies. So we can say that the traffic from container A can go to container B, and no one else can talk in between. Any other questions? Yes?
Thank you so much, Mohammad, for a very good presentation. I have a very basic 2 questions. First is, what does native mean in the term cloud native
Yeah.
environments? And I forgot the second. But you can answer the first.
Yeah, I would say that we could just go back to the official definition. So, yeah. Ooh, tough one. So, we have some. For instance, you have a business. You want to run your application somewhere. The very first thing is that you could buy the hardware, configure them, and then it's your environment. You have the full responsibility of everything. But when we are talking about cloud computing, it basically means that we are renting that environment. So, and cloud native is basically it's an approach, is a technique of deploying applications. So we could use that environment. It could be private, managed by us or someone else, or it could be public. For instance, consider like hyperscalers, and then we want to connect. How would I say? Make our application of really small, loosely coupled microservices that are resilient and manageable. So instead of, for instance, starting a VM, for instance, let's say one of the application is running on top of a VM. What happens is if that VM is being killed or some instance happening that. With this approach, we could basically just create a new container. It's super fast, but with VMs, it's not really easy. And for when we are talking about cloud native, it's just this approach of just breaking the applications. It might be a bit tricky for application developer because we have learned as application developers that we have to write and implement an application that should be resilient and run forever. And most of the time, it should be stateful to some extent. But with containers, the basic idea is try to not have a stateful. Try to make it a stateless so that if it's being killed, nothing happens. You just create another container. Yeah.
Thank you so much.
Thank you.
The second question is about when you mentioned containers, you mentioned that Kubernetes is most popular one or the one that you prefer?
The Kubernetes itself is a container orchestrator.
Yeah.
And it can run thousands of services. I think I've seen a report of running 500,000 container on top of Kubernetes. So it's really planned scale.
Yeah, my question is, I know the concept of containers.
Yeah.
The difference between a container and a virtual machine. Container is image, and you get to, it's lightweight, and it's runnable in virtual machines. Basically.
Yeah.
And I think the first popular solution for that was Docker.
Yes.
And then Kubernetes added something. Or I'm not understanding it right.
So maybe the whole idea of to answer that question, let's say that we have a Linux system. So basically, you could create a namespace by command, a network namespace, and then run your application in that namespace, and then create some virtual adapters, and then wire them to the host network. So, for instance, solutions like Containerd, Docker, they are basically automating this process. They create that network namespace. They have to do that, and they create those networking solutions, network adapters to connect them to the host namespace. So this is what they do. But what happens if we have, for instance, 3 VMs and we want to create a container, deploy a container on top of that. So we have to schedule it somewhere. In normal case, when we don't have Kubernetes, we have to just check out, for instance, how much is the resource consumption on different machines. And if, for instance, one has less, then we just create that container on top of that. And we have to SSH there and just, for instance, put the command docker run this container. But we don't want that. We want to automate this process. Kubernetes tries to automate this process, and also it makes sure that the container is running. And if you want to scale it, if you want to, for instance, have multiple instances of that, it's just one configuration file. You can change that easily.
Thank you so much.
Thank you. Any other? Yeah?
One more
Yeah?
question. That thing, Prometheus, that was to surveil the whole thing. I mean, that is sort of built into Kubernetes already, some sort of thing. So what does that add, like monitoring-wise, to just using the built-in monitoring in Kubernetes?
Kubernetes does some health check, but it's not enough. So, for instance, you want to see what is happening. For instance, if you want to see how much resources are you using on, for instance, some machines, you have to install a plugin for Kubernetes. So, and also more than that, we want to make sure, for instance, an application is running perfectly. So the easiest way is to, for instance, every 5 seconds, we check that application from inside, or that application sends a notification to one database. And actually, Prometheus does that. And also, it also helps us with the query part. Also, it can be really well integrated with, for instance, Grafana. And also, you have the alert manager in Prometheus that if something happens, it does the alerting, for instance, to your medium that you're using. For instance, I want to receive an email, or I want to receive a message in Slack. We could somehow configure that, also schedule those, organize that in a way that those things happens. And this is what Prometheus does. And what else? Anything else that you can add? Yeah. Mm-hmm. Yeah. Yeah, exactly. And also, personally, I really like the libraries that Prometheus has. So you can basically just, you're developing, for instance, a PHP application. You can just talk to Prometheus API directly from within your application. This is the other thing that it has.
Right, so you put in some monitoring points in your code.
Yes.
Just
Instrument your code based on what you need.
so it's like Google Analytics, which I use for like Android apps and stuff.
Mm-hmm.
Like Firebase-based analytics.
I'm not familiar with those.
It sounds like that.
Maybe, but it's free. There, yes. Also, it's for free. It's open source.
I guess you could just put in whatever metric you want to if you can call some API.
Yeah. Mm-hmm.
Yeah, exactly. That's what I mean. So, I mean, it sounds like you could do. Yeah, it sounds like you can do what you do with the Firebase. Yeah.
Mm-hmm.
Right. Excellent.
No worries. Yes.
So we've used Prometheus for business metrics as well, like when the client comes and it's like, why are there delays in the system, and then we have our own custom metrics for queues,
Yeah.
things like that. So I think for us it was like, when you have like a JVM or something that's pretty standard that you want to monitor.
Yeah.
It's really nice that there are a lot of built-in tools.
Yes.
But then also you can add your own like metrics for business
Yes.
logic.
Yeah. Yeah. And how are you? By the way, how are you using that? For instance, do you use the libraries or do you send them to push gateway?
We had an operator deployed
Okay.
in the cluster, so it was constantly like you just added an annotation in your Kubernetes manifest, and then it polled the application, and then we used a library that made sure that the metrics were available.
Nice.
Yes.
That's the best part. Yes.
I think you present a really brilliant solution at the end, where you say it's open source and
Yes.
you combine all the solutions. Could you please put that in context with the very first image, where you show way too many more applications?
This one. So maybe I can talk about this one. It's the CNCF landscape. At the moment, it has 184 projects in different categories. For instance, it has database, CI/CD, streaming and messaging, remote call procedure, service meshes, scheduling orchestration, and service proxy, and so many more. We want to choose something that is not going to die really soon, and also it has a huge community that is going to be developed over time. So CNCF itself has some procedure for that. For instance, you could just check some of them. For instance, Kubernetes itself is a CNCF graduated. So it means that there are so many users that are using this, and there are so many people also that are developing this, and it's well established. So we could basically just use these tools that are graduated and connect them together to build our own solutions. But we want to also configure them, because sometimes configuring them might be a bit tricky. Yes? The compliant Kubernetes. Yes. For the compliant Kubernetes, you mean, or for the Kubernetes itself? Actually, you can set the verbosity of the systems, so it can talk a lot. I have no idea. Do you have any idea? That guy or that guy? Yeah. Yeah. Yes. Mm-hmm. Yes. Yeah, I can talk. We have different partners. For instance, the recent one is Azure, that we can run on top of that. And also we have other partners, providers mostly in Sweden. And the customers could basically just choose whichever they want. And also we are able to, we have tested our solutions with other providers, but maybe it's not production ready yet, but we are able to do that. Yes. Ooh, secret management. Yeah, SOPs, but it's for local, right? We use SOPs for local secret management, but in maybe you are referring to the secret management in Kubernetes itself, right? Yes. Mm-hmm. Yeah. Yes. Yeah. What do you have anything in mind?
We use Kubernetes where hard drives are encrypted at the server level, so we're not so much worried about encryption threat, right? So at some point, encryption keys are anyway in memory, whether you use vault or anything else. So what we do instead is that we make sure that the user repository is encrypted, so it's encrypted, right? And for that we use SOPs. And then of course they get converted. We use a first called help file and help secrets, which can then take a simple source file and a TCP key and decrypt it when the release is applied on the cluster. So it gets converted from unencrypted to create a secret.
Mm.
And then we use of course short testing that on the right people have access to those secrets. But SOPs and help secrets. You need two keywords to type in Google.
Yeah.
You're building a application and you have like a password for a database. You don't want to change it. Maybe you want to get to the application in Kubernetes in a ledger. May I ask the same kind of question? When it comes to secrets, so your customers, where do they enter the secret? That depends very much on them, right, and what solution they have. Some people actually still have team secrets on top of our clusters, and then they use team secrets for that. Some people just use Argo CD, and then I think Argo CD can integrate 10 secrets.
Mm.
Yeah, or
Yeah.
some people are using the Vault plugin, but that's not really something that we take care of. That's responsibility of the application.
Yeah.
But yeah, basically, seed secrets, source, help secrets, wrapped or not around Argo CD.
And with that, I guess I smell pizza. We have pizza here. So, thank you.